Hello viewers, welcome to another section of the Artificial Intelligence series. This happens to be the part 3 of the series. In our previous lesson, we discussed intelligent agents, and then in this section, we will be looking at the types of agents. Please, if you've not watched the previous one, I kindly recommend you going back to watch so you get much understanding. And if you find our content very useful, don't forget to hit on the subscribe button. And please click on the bell icon so you get notified whenever a new video is released. Now let's get started. Now we'll be taking you through this section. In our previous lesson, we discussed about the 5 classes of intelligent agents, being the simple reflex agents, model-based agents, goal-based agents, utility-based agents, and then the learning agent, with which we came up with a short abbreviation to be the SMGO. Now let's take them one after the other to see how they work. So in simple reflex agents, simple reflex agents work in a fully observable environment. When we talk of a fully observable environment, these are environments that do not change in state. Taking for example, within an office, the conditions within an office stays permanent and then do not change, as compared to that of the roadside where cars can come around, human beings can be crossing over, traffic lights can be turning on and off. With fully observable environment, they do not change in state. Their states remain constant throughout the period with which the agent finds himself. So they work using the condition action rule. So with simple reflex agent, let's first understand the meaning of reflex. Reflex simply means involuntary, that is working without thinking. So with simple reflex agent, they just perform action without thinking, only if a condition is met. So taking for example, you holding your hand with a soft substance, with a hot substance. Taking for example, you pick a bowl which is very hot, immediately you leave it to splash on the floor without thinking of the next action that will happen. So with simple reflex agent, they do not think before acting. Taking for example, a smoke detector. When a smoke detector is in an office, or let's say a kitchen, and it detects a smoke, it starts blowing alarm. It doesn't know whether it is fire or anything. So once the condition has been met, it starts performing the action it is supposed to perform. So these agents take decision on the basis of current percept and ignore the rest of percept history. So they do not keep track of previous occurrences. They just act based on the condition that happens. So these diagrams actually explains the simple reflex agent. So over here, it uses the sensor to perceive its environment. So taking the smoke detector for example, it uses these sensors to see whether there is smoke coming. So after it senses, the question comes, what is the world like now? So is there smoke in the environment or not? So once there is smoke, it comes over here, condition action rule. So once it has detected a smoke, it starts performing action. So once there is smoke within the environment, it starts performing action by blowing alarm into the environment. And then if there is no smoke, it stays silent. So basically, that is how the simple reflex agent works. They work without thinking. They work involuntarily. Once the condition is met, they perform the action. Let's move on to look at the second one, that is the model-based reflex agent. So with a model-based reflex agent, these agents work in a partially observable environment. So when we talk of a partially observable environment, these are environments that do change state. Example is the roadside. When driving through the road, many situations happen. There can be traffic, there can be um a car spot, and then the rest. So they actually change the state of the environment. So it works using an internal state and then a model. So with the internal state, it is a record of previous percept histories, previous occurrences. It keeps track of previous occurrences. And when we talk of the model, model is the knowledge of the environment. You get it? So it works by finding a rule whose condition matches the current situation. So per the model, it perceives the environment, takes it and then compare it with previous states before an action is performed. In other words, they think before performing an action. So let's take Google driverless car for example. When the car is moving and immediately detects two lights from a car ahead of it, it takes it to its internal state and then think over. When I see two lights from it's a car ahead of me, what does it mean? It means the car is braking. So once the car is braking, then what should I do? I need to also apply my brakes. So basically, that is how model based reflex agent works. So this diagram illustrates the activity of a model based reflex agent. So it first perceives the environment. So what the world is like now, what is the world like now? So as I first said, using the Google driverless car, it first perceived the car ahead of me has two red lights at the bottom, or the red lights is on. So it comes to each stage to check. So when the two red lights of the car is on, what does it mean? You get it? So that is how the world evolves. So if the car is braking, then what my actions do, or what should I do? So it comes in here, and then once there are two cars ahead of me, it is braking. So for that reason, I need to also apply my brakes. So the brakes is being applied back to the environment. So basically, that is how the model-based agent works. And we have the goal-based agent. So the goal-based agent is the extended version of the model-based agent. They mainly focus on its goals and then performs a sequence of actions to achieve its goals. So unlike the model-based agent, with the model-based agent, looking at the diagram here, over here, it works using the condition action rule, but with goal-based agent, they work using goals. So their main focus is to achieve a particular goal. Do you get it? So taking the Google driverless car, for example, in relation to goal-based agents, their ultimate goal is once I am driving, I am going to this destination, and then no matter what, they perform all sort of actions so that they get to their destination. So let's bring it to a practical example is students. When a student has a goal of achieving first class certification, he does all activities, performs all series of activities so that he can actually achieve its goals. Yeah, so with a goal based agent, they are focused on achieving a particular goal. Now let's look at the diagram, the illustration. So it is similar to that of the model based agents, but over here they do not work based on condition actions, but rather their main focus is on goals. Do you get it? So what action can I do to achieve my goal? So that is how the goal based agent works. Now let's move on to look at the utility based agent. So utility based agent is also an extended version of the goal based agent. They act based not only on goals but ways to achieve the goals. They are useful when there are multiple possible alternatives an agent has to choose in order to perform the best action. So over here, unlike the goal-based agent, which is focused on achieving its goal, with a utility-based agent, they focus on achieving a goal. They focus on achieving the best action. That is it, the best way to achieve a particular goal. So taking for example, we are going to a particular route. Yeah, we are going to a particular route. There are shorter routes that we can use as well as longer routes that we can use. With a goal-based agent, once it is looking to achieve a particular goal, it can choose to go to use the longer route. But with utility-based agent, they look at the best alternative which will help us achieve the particular goal. So instead of the utility-based agent using the longer route, it will rather use the shorter route in achieving that particular goal. So with a utility based, utility actually means satisfaction. So they choose the best option that will make them feel very satisfied. Another scenario is I'm going through a particular journey, and then you have the option to choose between a commercial driver, such as let's say the trotro drivers, and then the Uber driving. Do you get it? With the trotro driving, they can stop at any point in time and then pick people, which might delay you from though you will get your destination, but you will, in other words, or in turn, get angry or annoyed. But with the Uber, they choose the best alternative or the best route so you can get at your place in time and then with satisfying conditions as well. All right. So this is the diagram for utility-based agents. So they perceive the environment through the senses. They, so basically, this is how the model model-based reflex agent work. But over here, their main focus is on utility. How happy I will be in such a state. Their main focus is on utility. So as I've already given the example, you driving by Trotro and then Uber. At the end of the day, the Uber will give you much more satisfaction as compared to the Trotro. And for utility-based agent, they will choose Uber over the Trotro driving. And then the last agent we'll be talking of is the learning agent. So with the learning agents, they already have some basic knowledge, but in as much as they have basic knowledge, they improve its actions through learning. You get it? So based on their knowledge, they still improve. They learn to improve through learning. Sure. So and then also exploit new ways to get new knowledge. Do you get it? So example can be students. Students already have previous knowledge, but they improve upon what they already know by learning new items, and then they try to engage in new environments so they can explore new ways of getting new knowledge. So that is that of learning agent. But there are some components that makes up a learning agent, and then these components are one, the learning elements. So the learning elements are the component that enables them to learn new things within the environment. And then the critics. So the critics component is a component of a learning agent that tells him that there is more room for improvement, which pushes it to learn something new. And then we have the performance elements. All right. So with the performance elements, this is the component of a learning agent that provides him a measure to check if he's actually achieving the maximum or he's an underperforming. You get it? And then the last one is the problem generator. So with a problem generator, that is what enables a learning agent to explore new knowledge. Since when new problems come, they adapt to it, learn something out of it, and then improve upon their knowledge. So this is also the diagram of a learning agent. So they first perceive the environment based on their performance standard. Then we have the critic. That is, yeah, the critic, what tells them if something needs to be added to their previous knowledge or not. Do you get it? So if something needs to be added, or since if something needs to be taken off based on the feedback from the critique, they move on to learning agents and then make changes to their performance elements. Do you get it? That is the standard with which they check if they are performing well or not. So they make changes to it, and then after the changes is made, they gain new knowledge. And then if there is a problem generator, if there is a new problem in the environment, they work around it, and then as they explore, they gain new knowledge, and then the new knowledge is being added to their performance elements or their previous state of knowledge. And then with that, they perform best decisions in the environment. Alright. So thank you for watching our video. If you find this content very useful, don't forget to hit on the subscribe button and kindly hit on the bell icon so you get notified whenever a new video is released. If you have any question, please put it in the comment section and I will attend to you. Thank you very much. Have a wonderful day. Bye bye.